We now discuss radial side adjustment. In this situation, the shaft centers may be parallel but not coincident. Our task is to bring the two shaft centers together onto a common axis. The procedure is to set up the second clock against the outer edge of the driven coupling as you did in the radial top and bottom check. Zero the clock at 90 degrees to vertical. Rotate the coupling 180 degrees and note the reading and direction of needle deflection. Correction of radial side runout is made by adjusting the side adjustment screws on the same side by equal amounts. Firstly, loosen the two side adjusting screws on the side to which the motor has to be moved, and then carefully and in equal amounts tighten up the opposite side adjusting screws in small increments. Keep your eye on the clock gauge and stop adjustment when you see the needle move by half the measured deflection. As you secure the motor hold-down bolts, observe the two clock gauges. They should not move. If any gauge movement is observed, then all the alignment checks should be reassessed. We urge you now to practice the procedures demonstrated by following the instructions in task number 4 in your workbook. Obviously, there are other methods of making alignment checks. Some very sophisticated equipment, like this laser alignment setup, enables accuracies up to a few microns to be achieved. This is necessary for equipment such as high-speed turbine couplings. The procedures of alignment correction provided in this series are considered traditional methods, providing accuracies to within 0.05 millimeters. In subsequent programs, you will learn alternative methods of alignment correction, using other coupling types for purposes of demonstration.